Welcome and thanks for joining us. My guests today are Tricia Fitzmaurice. She is the Public Sector VP of Sales and Strategy for Rancher Government, and Brandon Gulla, the Chief Product and Technology Officer for Rancher Government. It's good to have you both with us.
Thank you for having us.
And you know, the theme today is modernization of applications and some degree to which they interact with infrastructure, which agencies are also modernizing. But application modernization goes through cycles in history, and we seem to be on the kind of the edge of a new one. What are the trends you see in application modernization?
Yeah, great question. So we're seeing a big shift away from the cloud all of a sudden. And I think a lot of that is not because the inherent benefits that the cloud provides, but recent trends and all things edge computing, we're seeing the need for AI away from the traditional cloud and closer to the data has provided a lot of velocity to open up the bounds of computing. So we all say computing is cyclical, whether it's the data center to the edge and then back to the data center, kind of like the mainframe to containers, and now we're looking at bigger clusters again. We're seeing that play out, and a lot of this has to do with the conduit or how that data is transported. 5G, private 5G networking has provided a great opportunity for the data to actually bounce back and forth from the edge to the traditional cloud faster. And that's providing a lot of opportunity for our government customers.
And also driving this, would you say, is the desire for better customer experience and better response?
Yeah, absolutely.
For the user.
So let's take the military, for example. So the military traditionally has what they call a mean time to decision, where they have to make a decision faster. They can't necessarily be in the theater of war and send data all the way back to the United States to process, make a decision, and then send back to the battlefield. There's any severing of communications along the way, obviously that's going to drop. So they need a way to be able to make decisions faster. That's where edge computing really comes into play, because it allows them to have sensors and the processing localized to their environment and be able to have those decisions faster without that reliance on the external platform. So that's where we're seeing a big shift from always relying on the cloud to augmenting the cloud and taking a lot of the benefits and services that the cloud provides and taking it with you no matter where you go.
Yes, so the cloud itself is not central to thinking, but really performance and outcomes are, which gives you a more maybe infrastructure agnostic approach. Would that be a good way to put it?
Yeah, so it's funny because we've seen, especially with the new workforce that's coming out of college now, they've always had the internet. They've always had AWS or Azure, where, for lack of better terms, they've been drunk on the elasticity that cloud provides. So everything is unlimited. So going into the edge or going into the battlefield where they don't have that high availability or that disaster tolerance just won't work for them. So we have to find a way to lift and shift those benefits of cloud and take them no matter where they go.
We knew going into this year, into this fiscal year, that Edge was going to come into our strategy in a big way. We saw our customers looking at, with the advancements in small form factor hardware, with processing units, that they were looking to they wanted to process their data where mission was actually happening. So we looked at that and said, okay, well, we need our solutions to be able to deploy out at the edge in the same way that they would perform out in the data center. So it becomes something where we look at it and say, well, we want to ensure that we're not increasing technical debt out at the edge. What we want to do is create the same footprint that we have inside a data center, inside a cloud, and make that available out to our customers at the edge. And that's been proving very successful this year.
And how does that translate to how people, agencies, customers are looking at their mix of infrastructure resources, let's call it? Data centers, clouds, edge. Sounds like they're moving back to a mix, again, depending on the situation.
I mean, financial analysts say all the time, you have to diversify your strategy. And some of that's led by mission and what their objectives are, but at the end of the day, it's a disaster recovery and a disaster tolerant risk mitigation as well. So we're seeing that. Of course, they're enabling their mission through low-powered computing or moving the data closer to the sensor and the compute closer to the sensor. But in reality, they also want that fault tolerance where if a site goes offline, whether through a bad actor or just physics, they want the ability to be able to recover faster. So this is a way for them to mitigate risk while modernizing their platform.
And so what we're seeing, as Brandon was talking about with diversifying their IT strategy, what we're finding is that we want to ensure that we have for our customers the ability to manage across wherever they deploy. So we're looking at wanting to ensure that our customers have the ability to own their own IT future, to be able to say, okay, well, we've got infrastructure, and we can take this infrastructure, we can deploy it in the cloud, we can deploy it in a data center, but we also have the ability to deploy it out at the edge and far edge and tactical edge, but still manage across from a single pane of glass. And that's been really important to our customers as we partner with them.
And that gets to the question that's kind of technical, but it's kind of strategic at the same time. And that is how you go about refactoring or modernizing, or for that matter, creating new applications. Because there was a long period in which the virtual machine was the way, and then that gave way in many instances to containerization. And again, it sounds like an arcane question, but I think it gets to what you were saying about this complete flexibility and portability of deployment.
Absolutely.
Yeah, it's a great question. Unfortunately, it's not a situation where one product or one solution can solve that problem for everyone. It's very, very unique to each use case, but you can formalize and actually simplify that by adopting open standards and open applications and open source software, to be frank. We've seen where traditionally certain organizations might have invested in a certain cloud provider or maybe a certain virtual machine hypervisor, and that's now become a risk for them and a technical debt as there shifts in industry. So what we want to do is promote organizations to be able to adopt open standards such as Kubernetes or Linux containers, and actually be able to lift and shift these applications in their IT modernization across infrastructures, no matter if it's public cloud, private cloud, on-prem, or even moving CPU architectures. One of the things that we've seen lately that's actually very exciting is where the AMD 64 architecture has been king for so long. It's known for being very power hungry, while very, very performant, power hungry, resource intensive when it comes to power, space, and cooling, right? So luckily the ARM 64 architecture, the same architecture that's powering your cell phone, and if you have a more recent Apple computer, what's the CPU powering that computer itself, actually provides a much higher efficiency rate. And we're seeing where organizations such as the US Navy is actually running out of power on these ships, utilizing data center on ships. So they're moving towards a more performant architecture such as ARM 64. So in order to lift and shift your application, you have to focus on standards that are open and flexible rather than a monolith that creates technical debt and restricts an organization from modernizing rather than accelerating it.
So just to clarify, in the hyperscale virtualization, that tends to be more proprietary, whereas the container technologies tend to be more open?
Yeah, and underneath the hood, they're utilizing the same software. But while, whether if you're on a hyperscaler and they provide, say, a database as a service, right? You're paying for that and you're reducing your own risk and your operational workload, but there's a cost to that. We've seen if an organization wants to deploy whether an open source or a traditional database product that can be able to be lifted and shifted from public cloud to public cloud, or even public cloud to edge, or public cloud to data center, it allows them that flexibility to move where the mission is most performant for them. For example, if a certain call them hyperscaler B stands up a new data center in Stuttgart next month and cuts latency in half to the battlefield, obviously you want to be able to lift and shift your application. The technical debt involved with reverse engineering and changing from one hyperscaler to another is massive. So if organizations can focus on these open standards that allow them that flexibility to move where their mission demands, it's nothing but opportunity for years to come.
And it's all part of that IT evolution, in my opinion, too. So we're looking at it and saying, IT modernization is all about being able to do more with less, right? So you took monolithic applications where the operating system was tied to the hardware, and you obfuscated the operating system from the hardware. Then you move into virtualization, which gives you the ability to put an application, multiple applications on one server. Move into containerization, it's again our ability to do more with less and keep that obfuscation from the overall existing infrastructure so that you can have that portability like Brandon is talking about. And when you're doing that with open standards, it just means for any customer that you have the freedom to move in whatever capacity you want.
So you say that lack of obfuscation, let's call it transparency, right? So technology always gets there first. Policy and workforce modernization always takes up the rear. And we've seen that, and there's been some great strides in the US government lately when it comes to IT policy and containerization and being able to push code to the battlefield or into production faster. We've said that writing a line of code today will take 6 months to get into the warfighter's hands. That's too long. Our adversaries are moving a lot faster than that. So thankfully, the US government has started to focus on inheritable security patterns and inheritable security controls and concepts such as continuous ATOs or ATOs at hello that allow you to almost have an express lane to modernization and to production to be able to get these benefits into the warfighter and into the mission environment's hands faster. So you can only do that by utilizing open technologies and open standards and giving the assessors and the cyber auditors that full transparency of what your code's doing underneath the hood and where that provenance comes from.
And in the container model too, then you have more flexibility in what you move. You may not need to move the whole equivalent of the VM
Absolutely.
from edge to data center or data center to cloud, but only the specific logic, and everything else is already in place a priori.
Yeah, you're absolutely right. So the concept that has existed on the internet for a few years when it comes to containers is like, okay, it works on your computer, let's ship your computer and let's call that a container, right? And where you could do that with a virtual machine, that might be 100, 200, I've seen 4 terabytes in size. That's not very performant when it comes to reusability, portability, especially when we're working with customers such as we are now, that are operating in a low Earth orbit and they only have 14 minutes of data transmission per day via line of sight to be able to transmit these images. You can't shove 20 gigs in that line or in that time frame just for one application. So by reducing the size as well as the attack surface, by breaking out that monolith into microservice-based architectures, you're providing yourselves a lot of opportunity, not just in the speed to mission, but in the accreditation and the security of the application as well.
All right, on that note, we're going to take a short break. We've been speaking with Tricia Fitzmaurice. She's Public Sector VP of Sales and Strategy for Rancher Government, and with Brandon Gulla, the Chief Product and Technology Officer for Rancher Government. I'm Federal Drive host Tom Temin. This discussion is Modernizing Government IT with Hyper-Converged Infrastructure, sponsored by Rancher Government here on Federal News Network. Welcome back to our discussion, Modernizing Government IT with Hyper-Converged Infrastructure. It's sponsored by Rancher Government here on federalnewsnetwork.com. My guests today are Tricia Fitzmaurice. She's the Public Sector VP of Sales and Strategy for Rancher Government, and Brandon Gulla, the Chief Product and Technology Officer for Rancher Government. I'm Federal Drive host Tom Temin and your moderator today. And before the break, we were talking about the virtues and limitations of total virtual machines and the whole VM era giving way to containerization. Does an agency have to choose one or the other? Am I a VM shop or am I a container shop, which gets into technical debt, technical strategy, even who you hire maybe? Or does it have to be one or the other?
We don't believe that it does. Our strategy, and again, talking about being able to ensure that we're reducing technical debt for our customers, we want to bring IT modernization and cutting edge technologies to them without having to increase their technical debt. One of our solutions, Harvester, is a hyper-converged offering that we have that deploys at the edge. We were focusing, really, our strategy was focusing on allowing it to deploy out the edge. It deploys, and again, small form factor hardware, it can deploy at the tactical edge, it can deploy at the far edge. What we've really seen is our ability to take that. We knew that it was going to be so important for that offering for us to get that in front of our customers so that they could look at how they didn't have to choose whether or not VM or container. It's able to manage both from a single entity. So that was something that we spent a lot of time focusing on.
Yeah, and what about the skills needs and the learning curve for people that are doing the work, your IT staff?
Yeah, great question. So we've seen the shift lately from CISA, where they're promoting secure by design, secure by default. And that's something we've been championing for years here at Rancher Government with RKE2, our flagship Kubernetes offering, which is secure by default. It has a much smaller attack surface and mean time to secure because we ship it in a secure state. We wanted to take that concept and apply it to all of our products, including Harvester. So what we've actually done is shifted the responsibility of securing the baseline of the installation from the end operator or IT staff to the vendor, being us. So we actually are producing what's called Harvester Carbide, which is our unique offering here to Rancher Government customers that actually ships in a secure state by default. So you're getting a pre-hardened image that actually is pre-stigged from DISA. We're working on with DISA right now to formalize and finalize our DISA stig for that secure baseline. But then we actually bring it home to US soil, rebuild the software, and wrap it in supply chain enhancements, digitally sign each image, and produce some enforcement mechanisms to ensure our customers are getting a trusted build that has a lot of those unique security guidelines that CISA, NSA, and DISA are all putting out as best practices for secure supply chain going forward.
Because there is that executive order that everyone still talks about.
Exactly. As signers of the CISA Secure by Design pledge, we wanted to ensure that our entire product set, that we were adhering to Executive Order 14028, and that was resident across all of our solutions. So everything that we've been working on and all of the technology and the technology security features that Brandon and his team have in our products are really focused around ensuring that we are meeting those secure baselines that are expected for our government customers.
At the end of the day, it's funny because while Trish is completely right, that we're trying to ship the software in a secure state, that's alleviating responsibility from that operator, from that IT staff. We're seeing that our warfighters are being asked to do too much these days. You know, they have to leave boot camp and then they have to take a Security Plus certification just to be able to use technology in the field. That's not going to get us to the outcomes we need from a government organization. So by bringing the security and this hardening in-house and making that the responsibility and honor of our team to be able to do, not only are we delivering secure software, we're alleviating those responsibilities and getting the code into the warfighter and operator's hands faster than ever.
It almost gets people back to the idea of defense in depth, because you can maybe then concentrate on protecting the network and the perimeter, the traditional way of security, but understanding the containers are each secure in and of themselves.
100%. Zero trust is a big buzzword for good reason these days, and defense in depth is very similar when it comes to a holistic approach of security up and down the stack. You can't just buy one zero trust product and have it secure everything. So we're seeing this defense in depth topic come up where you have to secure each layer of the stack, but do so in a way that doesn't compete with each other and doesn't make it harder for the operator to use. We like to push that model to the left and ship in a secure by design state, but still make the software applicable for most use cases. CISA coined a phrase that I use almost daily: less hardening guides, more loosening guides. By shipping a secure product, you have that assumption of security on day one, but still the flexibility of making it fit the use case where you have risk mitigations in place.
And if we're doing our job well as a technology provider to the U.S. government, it's our job to provide the solutions that enable them to just focus on their missions.
Exactly.
They shouldn't have to be as proficient in our solutions as we are.
And let's move up to the Roman numeral level, back to our outline here, and that is modernization and better performance. And CX, as the case might be, or as you mentioned earlier, speed to decision in DoD. Any good examples of agencies or programs that are finding success in this multiple way approach, keeping secure and also modernizing for transportability and interoperability?
Sure. I think that we're seeing it across the board. I mean, we got off the ground because our solutions are easily deployed in air-gapped environments, right? So we saw a lot of traction in our Department of Defense customers and in our national security customers. But what we're seeing now is it's really across the board. When you look at the federal space, The missions are very different, but how they go about supporting those missions from an IT perspective are not. So we can take the same lessons learned that we have in the Department of Defense and apply those to what we're doing with our federal civilian customers.
I'm going to bubble up actually what Tricia was saying, the fact that our customers are working in these air gap environments 89% of the time. But air gap is not just exclusive to the US government. There's a lot of opportunities in taking that mindset and applying it to commercial opportunities, edge opportunities. We've seen, no matter if you're working in a government installation or low Earth orbit, by taking the architecture in a way that you're not relying on public APIs or even public endpoints when it comes to running your applications, and taking this concept of air gap first and bringing those dependencies with you, you can actually operate in a much more continuous manner. So if your 5G connection goes down, or God forbid, a data center out in Ashburn goes down for whatever reason, your operations still need to continue. So by bringing your dependencies with you, adopting strategies that take air gap concepts into play, no matter if you're connected to the public internet or not, you have the ability to prosper in any environment. We've seen that in low Earth orbit where comms are low. We've seen that and we're proud to say that we helped the U-2 Federal Laboratory actually put Kubernetes and containers in the nose cone of a U-2 plane to actually perform operations in flight and container upgrades. That's huge, and that's something that you couldn't do through traditional internet connected means. So we want to give our customers the opportunity to be performant no matter the operational environment, the connection ability, whether you're DDIL or connected, or even land, sea, air, and space.
So you can say you have changed the engine while the plane is flying. It might be the compute engine,
sure,
but you've done that.
But I love that use case, because at the end of the day, there's some technical
Sure.
leaders within the US government that say, IT modernization, containerization, we'll get to that when we get to V2 of our application, right? If we can help modernize a 65-year-old bird, what other excuse does your organization have not to adopt best practices in containers today?
And we've got about 60 seconds left. Briefly, if you could just touch on the cost considerations for agencies in development and deployment of these technologies, because nobody has unlimited money.
I think it gets back to, again, ensuring that you're choosing the right technology that has the ability to scale and pivot with you in whatever direction you want, so that you don't have to go and recreate the wheel again if you want to move from your cloud offering to a data center, or from the data center out to the edge. You need to choose a technology partner that has the ability and the openness to allow you to, again, own your own IT future.
Right, so you're always going to have a situation of some operational cost, some capital cost, but it's never going to be 100% operational OX type of
100%. The technology platform and partner you choose should be an asset, not a liability and risk to your organizations. So by focusing on open standards and open architectures, you're ensuring your organization from not being locked in for years to come.
All right, some great thoughts. I want to thank today's guests. Tricia Fitzmaurice is the Public Sector VP of Sales and Strategy for Rancher Government, and Brandon Gulla is the Chief Product and Technology Officer for Rancher Government. I'm Federal Drive host Tom Temin. For more on this discussion, please visit federalnewsnetwork.com and search Rancher Government.